silicon conductive rectifier. It's somewhat like a rectifier only, it's going to work over there. What we are doing, we are concentrating on the gate terminal of the SCR only. If I give the power supply to the gate, there is a current flow through the gate itself. As I keep on increasing the current, what's going to happen with respect to the voltage? That is what I need to know that much. I am keep on increasing the current across the gate terminal of the SCR. What is the voltage of that particular gate? That is what gate characteristics of the your SCR. Now, in this case, there are circuit diagram. There's a circuit diagram. I'll show you the circuit diagram first. So this is the circuit diagram. Okay. What we are doing, the circuit diagram says we are applying the voltage towards the gate through a resistor. So we have an SCR. This is an SCR. This is an cathode. This is an anode. Leave it. Okay, anode and cathode is there. But my concentration is I need to go for gate. Gate terminal, I want to check that. If you want to check the gate terminal, we will be having through a resistor I am getting the voltage. That is already we have checked it in the previous diagram. Through a resistor, I am giving the voltage. But before applying the resistor, I am going to give one particular device called diode. We have D1, okay, D2, I'm having D1 and D3. Three diodes are going to be used to supply the voltage to your gate terminal, to supply the current, IG, to generate. Now, we have ES, that is this one. ES, which has been given to your anode to cathode. For this anode to cathode, I am giving a source voltage. Okay. Refer this diagram. Anode, cathode, I am going to give a source voltage that ES. I am giving the gate current that is IG, which is coming here. IG is coming here. Through a combination of three diodes called D1, D2, D3. D1, D2, D3 is there. Why we need D1, D2, D3? Why can't we directly give the IG? Why can't we directly give the IG? In the previous terminal, if you consider this diagram, if I don't give diodes, three diodes, there may be a chances of getting a leakage current, there may be a chances of getting reverse current, there may be a chances of getting negative currents over there. So, see, since I have applied a source voltage, there may be a source current coming here, there may be a source current coming here, there may be a source current coming from this negative direction, there may be a source current coming in this negative direction. Okay, this may affect your IG. To avoid that negative current, what I am going to do, I am going to use D1. See, ES has been given, current is flowing through this one, IA gate. Current is coming here, correct? As we have discussed in the previous circuit, I am giving the ES through this one, IIT is coming. Okay, now assume that IIT is coming here. This IIT, there may be a chance of a negative current comes over here, because through cathode it's going to come. Through cathode, it may enter your IG. To avoid that negative current, because this IG is coming here, so I want to avoid that negative current, I am going to use D1. D1 is a diode which is used to block the negative current. See here, D1 serves to limit the reverse voltage applied between the anode and the gate. Reverse voltage applied between the anode and the gate itself. We are having anode, we are having the gate. So to block that reverse voltage, we are going to use the D1. Where exactly D1 has been used? D1 is used at the bottom. Whatever the reverse voltage is there, that's going to get blocked. First thing. Second thing, D2 prevents the negative source current. D2 prevents the negative source current. Any negative source current comes into picture, it's going to prevent that. So D1 blocks the reverse voltage. Reverse voltage across anode and gate. D2, what it will do? Prevents the negative source current. Prevent the negative source current. And D3. What's D3? D3 is coming from here. Blocks the positive gate current coming from the supply. This current, whatever the current comes here, the same thing current come here also. Same. So that's going to get blocked over there. So D3 blocks the positive source current, D2 blocks the negative source current, and D1 prevents the voltage, that is reverse voltage, which is between the anode and the gate over there. So any reverse current, any reverse voltage or any negative source current, if it is there, that need to be avoided. For that purpose, we are going to use D1, D2, D3. I want to generate only pure Ig. It should not have effect of the source. It should not have the effect of the source what we are going to use here. The source should not have any effect on the gate terminal. So to avoid all those things, I am going to use the three diodes D1, D2, D3. So you should know what is the purpose of the D1, what is the purpose of D2, what is the purpose of D3. So once you know the circuit diagram, then you will come to know how exactly a plot is going to come out. Okay. So understood what is the role of a D1, what is the role of D2, what is the role of D3? All are basically prevents the effect of the source on the gate terminal. D1 is used for block the reverse voltage across the anode and gate. D2 is for any negative comes into picture, it's going to reverse that one. D3, any source current comes into picture, the source current ಏನಾಗ್ತದೆ ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ IAK ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Okay, I'm giving the source. Yeah, IAK comes here. This is in forward direction, but diode is in reverse direction. So diode becomes open circuit over this. So this IAK is going to block over there. No current will come and place in the gate. Okay, how they want the negative iದ್ರೆ ಇಲ್ಲಿ negative ಇದ್ರೆ ಅನ್ಕೊಳ್ಳಿ, negative energy ಇರುತ್ತೆ. So any negative reverse current ಕೊಟ್ಟಾಗ ಇಲ್ಲಿ negative current ಬರ್ತಾ ಇರುತ್ತೆ, but diode is positive, negative current will not enter into this one. So D2 is main to any reverse current comes into picture, it's going to block that one. Here also effect of the source is going to get blocked, and the voltage across the anode and gate will be blocked by using the D2. So these are all the three functionalities comes into picture. So the graph, very important for gate characteristics. Let us see how exactly it's going to work. See, only slide, it's okay, but step by step you know, then it will be easy for you to write the gate characteristics. As I said, gate characteristics is measured with respect to the Ig versus Vg. Ig is the gate current and Vg is the gate voltage. Okay, so with respect to two values, I'm going to get like this. This is M, this is N. Okay, M and N, two different values, 0 to M and 0 to M. Okay? I will be having two gate currents, that is Ig minimum and Ig maximum. Between only I should check that. In the previous graph, IG1, IG2, IG3 we have checked, no? So what should be the IG minimum, what should be the IG maximum, we should give that. Okay, so I will be using IG min and IG max. This is IG1 or IG min and this is IG max. Based on this, I will be in the position to measure what is the value of your VG min and VG max. The value of VG min and VG max, I am able to identify that one. Okay, am I IG min? Am I IG max? Okay, so based on this, I am able to find VG min and VG max. So this is one point, this is another point. Okay, now I will be a voltage. This voltage has to be mapped with this. Voltage has to be mapped with this. You will be getting one more terminal, one more point called T. Okay, so this is they are given IG min, IG max, and then draw the load line. We call this a load line. This is a load line. When you draw the load line, you're in a position to identify the value of T. Okay, so we will be having S2, S1, 2 points, and whatever we are going to get in between values, these two. This shaded portion is what we are going to measure that. That is what the gate characters we are going to call. We need to know what should the R value, what should be the IG value, IG minimum, IG maximum. Based on that one, I want to find the H and also, okay, see here one more thing they have given. S2, S1. This is for with respect to R max and this is with respect to R min. Because depending on the R value, my current and voltages keep changing over there. But here, in the previous case, I have given you this is what I have given. So this is R changing. This is EG. So R maximum, R minimum also you should know that one. So once you know that one, R max, you are going to get reverse proportional. I and R. When you want to measure E, it's equal to I into R. Correct? No, V is equal to I into R. If R is large, I is small. If I is large, R is small. Correct? No? Okay, V is equal to IR. As current increases, resistance decreases. Or as you increase the resistance, current flow increases. A regulator, simple regulator, you know that one. Resistance is high, current flow is low. Resistance is low, current flow is high. Correct alva? Regulator lena gata. Resistance tumba high itre nim current flow tumba kadme irutte, fan rotation tumba kadme irutte. Resistance na kadme madadashtu current flow jaasti agutte, then your rotation will be increasing. Similarly, in this case, IG minimum, we are going to get resistance maximum. IG maximum, we are going to get resistance minimum. I am going to get that. So, based on the R maximum and R minimum value, we are in a position to get the what is the actual value of your current and voltage across the gate. Gate current and gate voltage, we are going to measure that. So, it's been given by using the gate current of I magnitude. By using the gate current of high magnitude, gate current high value, we are able to, it should be ensured that the pulse width is sufficient to allow the anode current to exceed the latching current. Yen madbeku, latching current ide, adikkinta jaasti madbeku, current na flow madbeku. Yav riti, I should appropriately give the gate current. If I don't give the gate current, proper gate current, like this IG1, IG2, anode current increase agodilla. Should increase properly. Adu correct increase madilla antare anode current increase irutte. Because here, once you give the proper gate current, then your current will increase. It's not increase over there. Breakdown voltage ಕಡಿಮೆ ಆಗುತ್ತೆ, ಇಮಿಡಿಯೇಟ್ voltage ಕಡಿಮೆ ಆಗುತ್ತೆ, current increase ಆಗುತ್ತೆ. Current anode current increase ಮಾಡಬೇಕು ಏನು ಮಾಡಬೇಕು? It should be greater than IR. You should give the proper gate current such a way that when your anode current is greater than the latch current. You should give a proper gate current. Gate na correct ಆಗಿ ಸೆಟ್ ಮಾಡಬೇಕು. ಏನಕ್ಕೆ ಅಂದ್ರೆ ನಿಮ್ಮ ಥೈರಿಸ್ಟರ್ ಕಂಡಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ. If you don't set the gate current properly, your current will not flow. It will not be in the forward bias. You are not going to get the gate current. Okay. So it should be ensured that the pulse width is sufficient enough. Pulse width is sufficient to allow anode current to exceed the latch current. Anode current to exceed the latch current. Latch current ginta ಜಾಸ್ತಿ ಇರಬೇಕು. IA should be greater than IA. In practice, the gate pulse width is usually taken as the equal or to greater than the SCR turn on time. SCR turn on time or turn off time ಅಂತ ಇರುತ್ತೆ. Okay, SCR time ಸ್ವಲ್ಪ ಹೊತ್ತು turn on ಆಗುತ್ತೆ, ಸ್ವಲ್ಪ ಹೊತ್ತು turn off ಆಗುತ್ತೆ. Okay, so it's a pulse. This is on time, this is off time. Okay, this is the entire time, overall time of the SCR, on off time. So it should be taken such a way that when the gate pulse width is usually taken as equal to or greater than the turn on time. Turn on time ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತೋ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. ಯಾವುದು? ಗೇಟ್ ಪಲ್ಸ್ turn on time, that is T on. T on ಗಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. To see T should be the pulse width. T is the pulse width. Okay, of the gate, the pulse width of the gate should be greater than turn on time of the gate. That means T should be greater than T on. T should be greater than T on. That is what has been given. Greater than or equal to, at least equal to or greater than. With the pulse firing, pulse ನಾವು ಕೊಡ್ತಿದ್ದಂಗೆ gate current ಕೊಡ್ತಿದ್ದಂಗೆ, if the frequency of the firing F is known, if you know the frequency, the peak instantaneous gate power dissipation PG maximum also we are able to calculate. So once we know the PG, we get PG maximum, which is given as PG into IG. PG into IG calculate ಮಾಡಿದ್ರೆ you are going to get the power dissipation you are going to get it. IG value ಮತ್ತು VG value ಎರಡು ಗೊತ್ತಾದ್ರೆ how much power is going to dissipate. Okay, so this is IG value, this is IG value, this is VG value. Once you multiply both of them, you are going to get the what is the power dissipation over there. This is IG value, this is VG value. Then when you know this one, the maximum power what we are going to dissipate, we will be able to get that. So IG maximum into VG maximum, if you multiply, you are going to get the maximum power which is dissipated. So which is being given as, once you know VG maximum and IG maximum, which is equal to average, you need to calculate VG average. What is the average? That is power dissipation, average power which is dissipated across the G and the gate. Okay, G and the gate. P maximum, I maximum we can call, but since we are concentrating on the gate characteristics, PG maximum, we have to go for that one. So how to calculate PG maximum? PG maximum is equal to VG into IG, that is equal to PG average divided by frequency into time. That is pulse width. So F is 1 by T1, that is T1 antandre on time. Overall time it's going to give that one. Overall time, frequency of the firing of a pulse or repetition rate. T is the pulse width in the second. Once you know this, you're able to find out the what is the value of your power PG maximum, which is equal to PG average divided by F into T. Once you know this F into T, where F is equal to 1 by T1. What is T1? Overall time. T1 is overall time. Check it here in this one. T1 is this. T1 is been given here. This entire time is the T1. This is T on time. Only on time. T is on time. T1 is the overall time. T on plus T off both put together is T1 will follow. So very simple, no complication. What's the condition? What is IG value? What what is the minimum voltage we are getting, what is the maximum voltage. Once the load line, we are able to find out VG maximum, IG maximum, VG minimum, IG minimum. Once you know this, we are able to find out the power dissipation. Stay, characteristics very end. Power dissipation of calculation. Once you know the power dissipation, you are able to find out what is delta, that is duty cycle. Usually duty cycle ಕೇಳ್ತಾರೆ ಅವರು ಅದನ್ನ. Duty cycle ಅಂದ್ರೆ ಏನು? Very simple. T on time divided by the overall time. T on time divided by overall time. That is duty cycle. Duty cycle of ಯಾವುದೇ ಒಂದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Duty cycle ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. On time ಎಷ್ಟಿದೆ? Overall time ಎಷ್ಟಿದೆ? Simple ಆಗಿ ಹೇಳಬೇಕು ಅಂತಂದ್ರೆ I will relate to my class itself. Overall time duration is 50 minutes. Class duration is 50 minutes. Correct? My class duration is 50 minutes. In that one, how much time I have given teaching? I have explained. Overall, it is 50 minutes only I should take. But in that one, what is the explanation? I have taken only 30 minutes. Remaining 20 minutes, I was not doing anything. I was totally idle. Total time is 50 minutes. But in that one, I taught only 30 minutes. Remaining 20 minutes, I was kept quiet. So, what is the duty cycle? 30 minutes divided by 50 minutes. Percentage calculate ಮಾಡಿದ್ರೆ ಎಷ್ಟು active ಆಗಿದೆ, ಎಷ್ಟು inactive ಆಗಿದೆ. So, active divided by overall time na calculate ಮಾಡಿದ್ರೆ only 60% I could able to teach. Remaining 40% I was not doing anything. Similarly, gate pulse, T time it was on, and total time is T1. On time is only T. On time is only T. Total time is that is T plus that is on time plus off time both put together. You are going to call T1. Inno simplify ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ನಿಮಗೆ ಈ ತರ ಬೇಡ ಅಂತಂದ್ರೆ you can one more question. Duty cycle is equal to T on divided by T on plus T off. This is very simple. T on plus T off is total time. Total time. T on is only how much time you are on. Okay. So this is given as duty cycle. ಯಾವುದೇ ಒಂದು field ಅಲ್ಲಿ ತಗೊಳ್ಳಿ, any field, even if you want to go for the analog circuits, analog electronics, digital electronics, everything you go for that. How much is the on time? What is the total time? On time divided by total time is called as a duty cycle. ಎಷ್ಟು ಡ್ಯೂಟಿ ಮಾಡಿದೀವಿ ಅಂತ ಅರ್ಥ. How much duty we have given? 60% only time only I utilize in the class. Okay, it's not only applies to me, even if you are applies to students also. Even though 50 minutes is the class, you are active only 40 minutes. 10 minutes you are not concentrating. You are concentrated on the class only for 40 minutes. Remaining 10 minutes you are not there. Or one more thing, I started by 9 o'clock. Some students have entered at 9:10, 9:15. Okay, so how much time they were there in the class? Total time is 50, but they entered 15 minutes late. They were there only for 35 minutes. So 35 minutes divided by 50 minutes is the actual duty cycle, we'll call it. How much time you are active? That is what duty cycle. Okay. So once you know delta, that is enough for your gate characteristics. Okay. Then with that one, you are able to find out what is PG average divided by delta. You are going to get the PG minimum. Always average will be less than the maximum. Average will be less than the maximum. See here, this is maximum, this is minimum. Average of these two if you take, it will be here only. PG average. Correct? This is maximum, this is minimum. When you take the average of that, it will become less than that only. Maximum will be always greater than the average value. So, which has been given PG average divided by delta, which is less than the PG maximum. That is what you are. Gate characteristics. What is gate characteristics? You will be finding the IG, you will be finding the VG, you will be finding the IG minimum, you will be finding the IG maximum. With respect to that VG maximum, VG minimum, you are going to calculate. Then you will find the what is the duty cycle of it. Duty cycle is basically calculated with respect to the pulse width of the gate towards the T on time. Okay, so pulse width T should be greater than T on time. T should be greater than T on time. T is what? Your pulse width. And T1 is what? Overall time. On time plus off time both put together T1. So if you are getting confusion, you can go for T1 plus T1. Okay. This is entire overall time. This is your pulse time. That is active time. So that is your gate characteristics. Next topic is thyristor turn on. How exactly we are going to turn on the thyristor? What is the mechanism we are going to use to turn on the thyristor? Thyristor on ಮಾಡಬೇಕು. ನಾನು ಆನೋಡ್ ಮತ್ತೆ ಕ್ಯಾಥೋಡ್ ಕರೆಂಟ್ ಕೊಟ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಬಟ್ ಅದು ವರ್ಕ್ ಆಗ್ತಾ ಇಲ್ಲ. It is not working. Okay, let us see. Let me go for it. Just a second.